So you guys probably remember last year when my favorite car battery shorted out, so I cut all the plates out of it, made it really light so I can use it as like a prop battery. But the main intention for it was so I can put lithium ion cells in there, so I could use it for when I go camping and whatnot, and it would still be effective, and it would actually hold more power than it did originally. Well, I've kind of decided I need the cells for another project, but whenever I pulled the battery pack out, I noticed that one of the packs was at 0.9 of a volt, which is very low. So I charged it several times, and the voltage keeps going down. So evidently one cell inside of here is pulling the voltage down. Let's take that out and inspect it, because that's weird that it pulls the voltage down, but it stops at 0.9 of a volt. Well, this pack seems to all have good cells in it, so I'm going to see about charging it while I'm messing with the other ones. These four look okay. That one looks like it might be bad. Still looks okay. Looks alright. Looks good. Looks okay. I think the culprit might be this one. Only one way to find out. Charge it and see if it dips in voltage a lot. Take a few magnets. Bring up the voltage. That's charging pretty fast, so even if it isn't broken, it's probably a very low capacity in it. Okay, that's enough charge for now. We'll disconnect it from the power supply and connect it to my 6.5 volt or 6.5 segment multimeter, and we'll see how much it declines, because it should stop in like a couple seconds, but it looks like it's still going down. I think this cell might be the one that's dead. I come back a half hour later and it's still going down. That's a pretty bad cell. Might blow it up or something. That'd be kind of cool. So how I signify that cells are bad is I draw a line around the top. So it looks like that. So now what I want to do is I want to know for sure how much capacity each cell has. So I'm going to get each cell up to 3.5 volts. And then, when they're at 3.5 volts, I'm going to charge it with my iMax B6 balance charger. I'll only charge one cell at a time, or in the case of these, 4 cells at a time. Then I'll just divide the result by 4. But as the iMax B6 charges it, it will count up how much power it puts into the batteries, how many milliamp hours of power it puts in there. So, at the end of each charge, I can just write on the side of the battery how much capacity it has. And that'll help for putting them into battery packs that are more evenly balanced. It's hard to get the voltage right. I was trying to... It was too high, so I tried discharging it, but then that was too low, and I was going up, and... Oh, it just occurred to me. The iMax B6 has the function to charge LiFePO batteries, which are 2.7 volts, so maybe I can use that feature to get it up to like 3.6 or whatever. Okay, so I'll just change it so it'll be... We're charging to 3.6 volts. Okay, so instead of 3.5, we'll just do 3.6. That'll be awesome. The IMAX B6 actually seems to be pretty exact though, so that's pretty good. And that's done. Now let's try the actual charging. I'll go back and change it to charging nicely. And it's counting up the milliamp hours of current that is putting into it, and that's the number that I'll have to say how much current the cells have. I'll just divide it by 4 since I'm charging 4 cells at once. The results are in. It has 8.4 amp hours, so that's 2.1 amp hours for each cell. And of course I only charge it to 4.05, or right here it says 4.08, but it'll probably go down to 4.05 volts. 8377, that's the exact amp hours that it has, but of course each charge has a different amount from it because there's small variables in the voltage, so we'll say 2.1 amp hours each. I've gone back to using the universal power supply to initially bring these cells up to 3.6 volts, but then I still discharge them, or actually no, I charge them individually with the IMAX B6 to get the capacity that each one has. Well, they're working out really nicely. There's actually a lot more capacity in these than I expected, and that'll allow me to assemble the cells together so each parallel pack in a future battery will be equal, so I won't have to worry about them getting as out of balance. Well, after that I'm going to be using this, taking part of these and checking the capacity in these cells, but I think I'm going to make another video about a different method for these, because what I'm thinking is, okay, so here we have a very good cell. It'll lay down. We have a very good cell and we have a very bad cell. Alright, this is about half health. Well, only about 1.1 amp hours left in this cell. Well, if I were to charge these up full, I were to pull 1 amp from this, and I were to pull 1 amp from this one would dip in voltage a lot more than this one would. So I'm going to get several different capacity cells. Now I'm assuming these all have pretty much the same C rating, or the current to voltage rating. So what I'm going to do is I'm going to plot out a graph, and then whenever I get a cell like one of these, I'll just charge them up and then I'll pull 1 amp from them and see how far down the voltage goes. And then what I can do is I can see where on the chart it is, and then I can tell how much capacity it has, or at least a rough estimate. Well, I hope you enjoyed this video and thanks for watching. See ya!